So what is induction heating? Well, induction heating is a flame-free, non-contact method of heating metals. How does it work? Well, there are a number of ways to explain that, but actually we think it's more interesting to show you. So here I have a handheld transformer fitted to quite a smart pistol grip. We're going to use this in quite an unsmart way just by turning the power on with the trigger. And fitted here is a single turn coil, encircling coil, and we're going to run a high frequency current through this coil. In fact, this system automatically matches to the coil and the part that we're heating. So in this case, we'll be around 20 kilohertz, which we would class as a medium frequency. If I take a metal part, any metal, any electrically conductive material actually, place it inside the coil, when we run the frequency, we get a magnetic field and the currents are induced into the surface of the part, giving us heat. So here we go. As you can see, I can put in heat exactly where I need it. I'm not getting hot. This stays cold. And it's very efficient. In fact, with our equipment, this is carbon steel, by the way, a solid bar. With our equipment, we even have low voltage on the coil. So if you did happen to touch the coil, it would be quite safe. How is this possible? The answer is surprisingly simple. Induction exploits the laws of electromagnetism in order to produce heat directly in the workpiece. The workpiece is placed in the coil, where this field induces a current in the workpiece, which generates heat in the workpiece. The coil, which is water-cooled and cool to touch, is placed around or adjacent to the workpiece. It does not touch the workpiece, and the heat is only generated by the induced current flowing in the workpiece. A correctly designed, made and maintained coil is crucial to the outcome of any induction heating operation. After all, it is the component that actually delivers heat to the workpiece. EFD Induction has years of experience designing and supplying customized, long-life coils for the full spectrum of applications and material. Of course, the technology behind induction is rather advanced, but at EFD Induction, we figured out how to use this amazing technology for practically any industrial heating application. Induction heating can be used for hardening, tempering, brazing, forging, melting, pre- and post-heating, straightening, welding, annealing and normalizing, and so many more specialist applications.
An induction burner consists of a ceramic plate with an electromagnetic coil beneath it. When you turn on the burner, an electric current runs through the coil and generates a fluctuating magnetic field, but no heat in and of itself. However, once you set an iron or stainless steel pan on the burner, the magnetic field induces many smaller electric currents in the pan's metal. Iron is a poor conductor of electricity, so as all these small currents run through the iron, much of the energy is converted to heat. Thus, on an induction cooktop, the heat is coming not from the burner but from the pan itself. This can make for more efficient cooking. A pot of water will come to a boil on an induction stove in almost half the time of a standard gas stove. You're also less likely to have hot spots in your pan where food gets scorched because it has more contact with the heat source below. The drawback is that only pans made from iron will work with induction stoves. Pans made solely of copper or aluminum conduct electricity too well to generate significant heat. Cast iron, stainless steel, and pans made with layers of stainless steel all work. As a rule of thumb, if a magnet will stick to it, you're good to go.